LeetCode problem number 130, surrounded regions. So this problem gives us a m times n matrix board which contains x and zeros, x and o's, right? So we have to capture all the regions that are 4 directionally surrounded by x. The region is captured by flipping all zeros into x in that surrounded region. So what it means is, if you see here, this O, so if we flip, let's say if we flip this, right, and if we flip this, that means this O is technically surrounded by 4 axes, right? So we can flip this as well. And using the same thought process, you can apply them to this as well, right? If you flip this, then it will be surrounded by 4 axes. And if we flip this, then this O will be surrounded by 4 axes. So all in all, these 3 O's can be flipped, right, and they will be surrounded. For this O specifically, since there is no O here, there's no X here, sorry. Since there's no X here, we cannot flip this O, which means that this O can never be captured, as it is at the edge of the board. So with this in mind, let's say this is an O as well, and this is an O as well. Since we can never flip this O, technically speaking, this O cannot be captured as well, right? Because it is not surrounded by 4 axes. And with that said, this O over here cannot be flipped as well, because it is not surrounded by 4 axes. So the main point is to look at the O's at the edge and run a depth search from there to see whether or not there are any connected O's. For example, just now, if there are any connected O's, which means that we cannot flip them. Okay, so with that in mind, what it wants us to do is to just flip the board. We don't have to return anything because this board is passed in by reference. So with that said, as I mentioned, I'll have a depth search function. So this depth search function works very similarly to a flood fill function. All it does is at start, there's a boundary checking to check whether or not we are at the correct cell. If we are, we change the value of that cell to a hash, for instance, and then we continue on recursively search through the up, down, left, right cells of the board. That's pretty much what a flood fill is, right? In this case, I name it depth search. Either way, they work the same. And in our solve function, the main function, so here I initialize m and n first. So m being the row size, n being the column size. So as I mentioned, I will be iterating through the edges of the board. So here I'm iterating through m, which means you can see here 0 and n minus 1. So these are the left and right. So I'm performing depth search on here and here for this for loop, and for the next for loop it will be performed on here and here. Okay, so for every cell that I've visited from the edge, we know that we cannot flip them, right? So what I mean by that is, let's say this board, uh, right? So this board, okay, let me just make some more. Okay, so let's say we have this board. So we know from the edges, right? We know from the edges, these 4 cannot be flipped, and these three can, right? Because as I mentioned before, there's never a chance that we can flip this because there is no x here, right? There's no x here, so we cannot flip this x. So what I will do instead is, let's say I color these. In this case, my color would be using the hash, right? I'll be using the hash. So I'll mark it as a hash, and then once that is done, the rest of the O's I know can be flipped. So here in this nested for loop, these two for loops, I'm checking if the board is an O, I'll just flip it into an X. If the current cell is a hash, which means we cannot flip them, then I'll leave them back to O's. You get what I mean? So at the end of the default search and at the end of the program, these will be converted into hash because they cannot be flipped. Right, so this is after these two for loops. Once that is done, here I change all the O's to X and all the hashes back to O's, which means we cannot flip these cells. And then we will have something like this, which is the answer. Alright, another straightforward problem, and hopefully my explanation and solutions are straightforward as well. With that said, that's all I have to show. Thanks.